Yes, so my name is Matt Warren. I describe myself as someone who likes low-level things in the .NET runtime. I also like figuring out what's going on under the hood or internals. I do a bit of blogging around those, and when I get a chance, some talks on those. So I also quite like working on profiling and diagnostic tools. That's been my sort of day job for a few years now. So helping other .NET developers figure out what's going on in their code is good fun for me anyway.
Okay. How are you enjoying the conference?
Yeah, it's good. It's good. I'm learning loads. It's a very specific but interesting to me lineup of type of low levels. Not all conferences go that low. Not all conferences would start with a talk like mine first thing in the morning. So yeah, it's been really good so far.
Could you briefly summarize your talk?
Yes. So I guess. I blog about what I consider the internals of the runtime. Now it's all open source, and there's design documents and other documents written by the engineers. You can delve into it at quite a low level. So I blog about that, but the talk was trying to look at it from the point of view of bits of the runtime that specifically do a lot of work to make our code run faster, so tying it in with performance, and also from a kind of idea of some of the things that we use day in, day out that we might take for granted, like a simple method call against an interface or value types that have been in .NET runtime for a long time. There's actually a whole lot of work going on in the runtime to make those as performant, to give us the guarantees, and so I was delving into that, so starting at the kind of high level stuff that we're all familiar with and just going all the way down to how it's implemented and why it's important, why it gives you performance.
Mm-hmm. What was the biggest surprise for you when you dive deep into the .NET runtime source code?
Yeah, a lot really. Certainly hats off to the engineers who write this stuff. It's one thing looking at it and figuring it out when someone else has done it, but to actually design this stuff, there's a lot of complexity. If the runtime gets something wrong, it can be really bad. You know, the .NET runtime runs on lots of places. So that was kind of surprise of just the complexity. But something I came across recently, and just written a post about it, is something called stubs. There's the post that goes into all the details, but they're just hidden everywhere in the runtime, and we use them all the time for when we do generic method calls, when we do interface calls, when we use pinvoke, those sorts of things. It's just surprising to me how much that idea, because they're hidden from us when we're debugging in Visual Studio. We don't see them. The runtime sort of hides them as implementation detail, but they're all chunks of small snippets of handwritten assembly code. So it just surprised me of how many places they're used, how much work must have gone into when you're talking about writing bits of assembly code. You know, they have to work for different CPUs. So that was one of the things recently I found that's been really surprising to me. Yeah.
And the garbage collector implementation in one file, it's not a myth.
Yeah, that's always the one. I guess I could look. Yeah, I think more people know about it now. But yeah, the 35,000 lines, and there's other big files in there as well. It's I think they sort of say, you know, it works. We understand the code. It's maybe challenging to get into, but it's good that other people are. I'm not the only one. Other people are sort of using the open source runtime as a way to, you know, before it was open source and the code was there, you could do some of this stuff via WinDBG, but I've noticed more and more people now are referencing the source and saying, you know, this is how it's implemented. You can link to the chunks of the code and stuff like that. So it's, but yeah, you're right. That 35,000, I wouldn't want to be finding my way around 35,000 lines of code every day, but I guess it works for them.
Yeah. You said something about tired compilation in .NET Core 3.0.
Yep.
Yeah.
Yeah, so it's been around since 2.0, maybe 2.1, but it was disabled by default, so people might not have realised it was there. But now it's turned on by default in .NET Core 3, so if you're using .NET Core 3, it'll be there. And very briefly to talk about it, it's the idea that the JIT could JIT a method twice, and it first of all starts with a simple version that the JIT can do that very quickly, and that helps with startup time, because generally on startup the JIT has to JIT compile a lot of methods in one go, and that can actually cause delay. And in the world of like microservices, where you're worried about starting your application up quickly, that can actually be an issue. So it says let's do the minimum optimizations first. That's very quick to do. The code it produces is not the most optimal, but actually for a lot of time it doesn't matter. And then the second step it does is it monitors the methods, how many times they're called. And when it considers them hot or have been called enough times to make it worthwhile, it has to go again doing the full optimizations. But this time it's done on the background. It's not blocking your code's running. So it's kind of trying to get the best of both worlds. Jit things very quickly on startup to not block the startup, but once you know which methods are worth optimizing more, I think I used the example of if you have a method that runs once a day and the minimum version is 10 milliseconds and the max is 5, that's not really what doesn't help you if it only runs once a day. If it runs 50 times a second, then that's worth doing. So that's kind of assumption, and then it does the maximum one. It switches the methods back out, and from that point onwards, your code will be running with the full optimizations we're used to in the JIT compiler.
Okay. Thank you very much. Enjoy the rest of the conference and the after party.
Thank you. Thank you.
Thanks.
No problem.